Hello, all of you. We are now beginning with the third unit of the topic, which is now going to give you the real picture of how crystals look like or how crystals are actually formed. So, in first unit, we had seen the types of crystalline amorphous. In second unit, two parts, we saw about different crystal lattice like BCC, body centered cubic, face centered cubic. You actually took the information that how FCC, BCC look like. But over here, now we are going to see how they are actually discovered, how they are formed in nature, and how they must be produced so that they get a proper three-dimensional picture. This topic needs a lot of imagination from your side. I have tried to collect as best possible diagrams as possible for you. We'll try to summarize, but frankly, from your side, you need a little bit of imagination to build the picture. Let us begin. So we are going to see now today the actual three-dimensional working, which is known as close packing in the unit cells. So whenever crystals are formed, constituent particles will try to come as close as each other. They will have their van der Waals forces, hydrogen bonding, whatever. And those atoms will come very close to each other, creating the crystal. Whenever they are coming close to each other, howsoever close they come, there will be some empty space remaining in them, which is known as void space. Crystal system will try to have minimum void space and use maximum available space. That's why crystals will have usually higher density. Now, to understand how the atoms create this whole picture, we first come to know a term called coordination number. So coordination number is that number of closest neighbors which are in immediate contact with the given atom. So for example, if you consider an atom, how many immediate neighbors are in touch with that atom? That is called coordination number. So we will keep this term in mind and we will develop the close packing. First, we will develop in one dimension, we will extend it to two dimension, and then finally to 3D. So this will give us the real proper picture of how unit cells look like. So let us now begin with linear arrangement or one dimensional arrangement. Before we start this, one assumption is made here in this topic that all the atoms are spherical. We are considering all the atoms are of equal size. That means if I take the crystal of aluminium, all will have aluminium atoms only and all will be of same dimension, spherical. In next lecture, the second part of it, we will be going for a topic where if different atoms are to be arranged, how they will be arranged. Like aluminium along with oxygen, sodium along with chlorine, where atomic radius are going to differ. That is my part number 2 of the topic. So today we are only going to consider a very ideal situation where all the atoms are of equal sizes. So we are now going to take here linear arrangement. So how linear arrangement looks like? Very simple. Just keep atoms next to each other. You can assume some round fruits like perhaps smooth oranges, or if you like sweets, you can assume laddus, and they are how they are arranged. That's how atoms are arranged, very similar way. You can see this atom, which I'm marking with a reddish color, is in contact with two nearest neighbors. This is what I called as coordination number. So in linear arrangement, coordination number of an atom is going to be 2. Any doubt before I now extend this to 2 dimension? This is the easiest one you can have. I hope this is very clear. Next one, number B, is 2 dimension. Now in 2 dimension, we are going to stack the rows of this same thing. There are two ways in which it can be done. Number one is like this. This is the same diagram what we saw. I have stacked another level of same type over it. Third one, uske upar fourth, fifth, seventh, imagine. Can you see here, if I pick up an atom, it is in contact with four its neighbors. So this central atom is in contact with four atoms. Coordination number is 4, and this arrangement is called AAA arrangement. By AAA simply means this row is labeled as A, second row is also similar to that, third is also similar to that, and so on. This is one of the way, number one. Any doubt in this before I go to the second one? Let us see the second one. This packing is called square close packing, obviously, because it gives you a geometry of a square. The second one looks like this. Watch very carefully. This red one, bottom row, and the upper one, they are not exactly over each other. In fact, you start seeing it from the green one. Look at the second one from bottom, and the upper one is kept on the depression created over here. So you can see these two atoms are creating a depression here, conical depression, on which the next atom is kept. Same way on these two, there is a depression created, next one is kept. So that's why this will be labeled as AB, AB, AB rows. If you now see this AB, AB, one of the atom is in contact with directly 6 atoms. This is called hexagonal close packing, which if you remember in D block elements, I had called as HCP. HCP stands for hexagonal close pack. Coordination number here being 6. Read the whole para. Anything in this 2-dimension one? Then before we go for after this now, 3-dimensional one. I hope the concept is clear so far. 1 dimension. Then we stacked the rows over each other. When the rows were stacked in a same way, AAA, that is called the square close packing. When it is in ABAB format, it is called hexagonal close packing. Let us now begin with 3-dimensional one. Now in 3-dimensional, real structures of course are 3-dimensional, and 2-dimension only is extended further to give a 3-dimension. There are 2 3-dimensional things possible. Number one, square close packing, and hexagonal, the one which we saw right now. So these two things can be obtained in following ways. Number one, square close packing. This is obtained by just extending the AAA arrangement. So this was our AAA arrangement. And now just roll this further in all the directions, somewhat like this. So what you see here as the first row, front row, are these atoms. There is another similar row behind, third behind, fourth behind, and so on. If you join the points, the centers of all these atoms, you can see you get simple cubic lattice or primitive cubic lattice. So at the corner, we have one atom, the one which we did in last 2 lectures. This is called the square close packing, leading in 3 dimension to the simple cubic or primitive cubic. Go through this. Any doubt you can ask me. Let us now go for hexagonal close pack. Hexagonal close pack we know is obtained from this ABAB arrangement. Now, if you see this one, ABAB arrangement, you will see we have marked something called T and O over here. Now, observe this very carefully. This is what we call as the void spaces, empty spaces. Observe this part in a little magnified view. Where you see as T, just observe that carefully.
inside the circle and O is
Okay,
outside.
but how many atoms can you see are making this T? Anyone can find out? The empty space T is made by how many atoms?
3.
Very good, correct. One, two and थ्री. सो आप लोग डायग्राम देखने के टाइम सिर्फ फ्रंट रो जो डार्कर सर्कल दिख रहा है ना उसके आप फोकस करो. इट्स अ इल्यूजन बेसिकली. So imagine these three atoms you are looking at, and these three atoms. Yesterday, as I said, this is head and the 2 years of Mickey Mouse. You can see Mickey Mouse sort of thing. So इस diagram का जो ये center है, this is called one type of void known as tetrahedral void. T stands for tetrahedral void. Now, second thing, watch this O which I'm showing you here. Okay, ये देखना, दूसरा कोई O मत देखना, कंफ्यूज हो जाओगे. ये O देखो. अभी आपको ध्यान देना है डायग्राम पे. Watch, this O is made up of the front three dark atoms.
And the behind also.
Yes, and behind the faint circular atoms, but arranged opposite way. ये देखो, ये आपका ऐसे एक उल्टा मिकी माउस है और इसके पीछे एक फ्रंट मिकी माउस है. कैन यू सी?
Yes, sir.
एवरीवन कैन अंडरस्टैंड दिस. आपको ये समझ में आया तो आपको नेक्स्ट आंसर समझ में आएंगे हेक्सागोनल क्लोज पैकिंग के. So this dark one circles are the front atoms above and the pale ones are behind the level. So there are two voids we study, tetrahedral void and octahedral void. So let us go in details of it. Then we will come back to the hexagonal closed packing. The closed pack structure always possess unoccupied space. We had seen in yesterday's derivations, like in cubic closed pack, 74% space was occupied, 26 was left vacant. Yesterday we did the derivations. This unoccupied space is called void space or holes. So just read up this definition. What I told here is just given in form of definition here. Now we will take up the information on the tetrahedral void. What is a tetrahedral void can be seen with this diagram. You see, these are the three atoms which are showing blue color. And on this, the fourth atom is placed. This first diagram which you see is a top view. Please understand, this is a top view. Second diagram is a front view. So in front, आपके सामने ये दो atoms को रखा है. इसके पीछे ये थर्ड एटम है और ऊपर से ये चौथा एटम इस पे प्लेस किया है. तो ये जब चार एटम्स प्लेस होंगे तो इसके बीच में जो वॉइड स्पेस रहेगा उसे हम लोग कहेंगे टेट्राहेड्रल वॉइड. इफ यू जॉइन द सेंटर्स ऑफ ऑल द फोर स्फीयर्स you will get a tetrahedral diagram, a 3D diagram called tetrahedron. Tetrahedron is a 3D image obtained by joining four triangular surfaces. So आप देख सकते हो, ये फ्रंट है, ये राइट, ये लेफ्ट और ये बॉटम. Four triangular surfaces. Please imagine this carefully. If you need any more explanation, tell me. Tetrahedral void is formed when a fourth atom is placed over the depression created by three atoms. So when you join three atoms flat on a surface and you place a fourth atom over it, the empty space between them is called tetrahedral void. Shall we move ahead? Everyone okay with this part? Let us come to an octahedral void. The one which I showed you earlier, it is this way. Front row, we have three atoms. Back row, we have three atoms kept in an opposite manner. So you can see at bottom. So this is top view. The middle diagram is the front view. So here we have front two atoms, back side rear one atom. इसके ऊपर जो एटम्स रहेंगे वो एक फ्रंट एटम है, इसके रेयर में दो एटम्स है. If you join the points, centers of all these six atoms, you get over here octahedron. octahedron. Let us check how many triangular faces you can see. First, second, third, fourth, fifth, sixth. Everyone got this thing? How to count? How many spaces are you getting here? Octahedron. What must be the number of points over here?
8.
8.
8. So can you see the 8 faces over here? Front, first, second, third, fourth, fifth, sixth, seventh, and eighth. You can better draw it and check also on your own. Number of atoms are 6, but the triangular faces are always 8. That is called octahedron. Tomorrow's lecture onwards, we will be starting with coordination chemistry. There again, we will be coming across octahedral and such thing in more details. Please go through this. I hope the void concept is clear. Tetrahedral and octahedral voids. So we come back now to placing the third layer over this part. So when you place the third layer in hexagonal, you can either cover tetrahedral voids and make it, or you can cover octahedral voids and make it. So for example, if you place on third layer over tetrahedral voids. So अभी डायग्राम जरा आराम से देखना. ये आपका 6 atom का layer है which I have labeled as A. Then there is another 6 layer atom A, and this atom, the central atom, is kept over here, which is a tetrahedral void. If I make this join together, it looks as complicated as this. I want you to picturize this very carefully. From the central layer, only imagine a tetrahedral void, which is in the center here. Remove all the other ones, imagine, and do it. I have done that in the next slide. So please read this process. When a third layer is placed over the second layer, such that the spheres covered a tetrahedron, three-dimensional close packing is obtained. I'm giving this better diagram on the next slide. This is called ABAB, or known as hexagonal close packing, HCP. Let us see this in a better way. This same diagram, now I'm going to simplify over here. Watch very carefully. This A is over here. From B, I'm only keeping the part which will give you a tetrahedral void. So ये आपके 3 atoms, और उसके ऊपर ये blue atom जब रखेंगे तो देखो tetrahedral void create होगा. Same way, ये 3 atoms को अगर नीचे से ये atom touch करेंगे तो नीचे से tetrahedral void होगा. इसी atoms को सबको join करके we get this picture, and a simplified one is over here. So watch, this A layer is over here, hexagon, center में purple atom, second level के ये 3 atoms over here, and once again the same level down. This is what we call as hexagonal close packing. In periodic table, it is seen with beryllium, magnesium, cadmium, zinc, titanium, molybdenum, so many of them. Packing efficiency of this is found to be 74%, and its coordination number is 12. Can anyone calculate and tell me how the coordination number comes out to be 12 for this? I want you to think and prove that it is 12. For simplicity, for guidance, one hint I'm giving you. Check this blue atom in the center and check ये कितने atoms के direct contact में आ रहा है. That is your coordination number. Try and tell me, prove it. It is 12. Take 1 minute if you want.
For single atom is 6, but there are 2, so there will be 12.
लेकिन वो जो 6 वाला जो लेयर है वो फर्स्ट है, उसके बाद डायरेक्टली थर्ड है, तो ये लेयर इसके कांटेक्ट में नहीं है. Am I right?
Yes, sir.
सोचो, anybody else?
So maybe the red ones
So,
are on contact with others.
so
Yes,
the
yes, yes.
six one, the around ones, that
Correct,
is six.
correct,
The
correct.
down ones, that would be three,
Very good,
and the upper ones, that would be three.
very good, perfect, very good. Let me show what he said right now. Perfect imagination. स्ट्रक्चर कुछ इस तरह से है आपका। ये आपका जो सेंट्रल एटम है जिसका हम लोग कोऑर्डिनेशन नंबर निकालने वाले हैं, एंड देन वी हैव 6 एटम्स इन दैट रो, 1 2 3 4 5 एंड 6। तो ये आपका रो है जिसमें, आई विल बेटर ड्रॉ इट अगेन, हॉरिबल डायग्राम आई हैव ड्रॉन, आई विल शो इट इन अ इजियर वे। ये आपका हेक्सागोनल एक लेयर है जिसमें आपके पास 6 atoms are present in that plane, and we are checking the coordination number of this one. So currently this is in contact with 6 atoms in this row itself. Then don't forget that iske niche 3 atoms were there, and iske upar फिर से there will be 3 atoms. So ये 3 atoms और ये 3 atoms, so total सबका हो गया 12. So this atom is in direct contact with 6 in the same level, 3 in upper level, 3 in lower level, total 12 atoms. The coordination number is 12. Has everyone understood this part properly? आपको इतना डिटेल में एग्जाम में कोई पूछेंगे नहीं, लेकिन आपको सेटिस्फाई होना चाहिए कि जो चल रहा है वो आपको समझ में आ रहा है. The problem with this diagram is we don't imagine again that B इसके ऊपर भी है. See, understand, this is an infinite layers. A, B, A, इसके बाद फिर से ऊपर B, उसके बाद A, ये चलता ही रहेगा. We have just taken out a small piece of the infinite crystal lattice. Is this all right? First one सबके समझ में आ गया. हम लोग ने टेट्राहेड्रल वॉइड को कवर करके ये पिक्चर बनाया है. Now we will touch the octahedral void, और इससे हम लोग को अलग पिक्चर मिलेगा. So that is called ABC ABC like this. अभी इसका पिक्चर उन्होंने जो देखो, एटम्स तो सब जगह रहते हैं, वो लोग क्या करते हैं, उसमें से थोड़े एटम्स को निकाल के आपको एक पिक्चर बना के दिखाते हैं. So see, now this is first atom layer A, which is placed over an octahedral void, which is exactly placed in an opposite way, and then once again same. So this is called ABC ABC. So if you touch, it will look like this. अभी इसको हम लोग थोड़ा सिंप्लीफाई करके दिखाते हैं. ये डायग्राम थोड़ा ऑब्वियसली कॉम्प्लिकेटेड है. अभी इसका जो ट्रांसफॉर्मेशन है वो देखो, जबरदस्त है. दिस इज इन अ लिटिल डिफरेंट कलर हियर, A, B, C एंड A. अभी इसी को हम लोगों ने क्यूबिकल फॉर्म में प्लेसमेंट किया है सेम वे, और इस क्यूब को 45 डिग्री रोटेशन से आप अगर देखोगे तो आपको ये पिक्चर दिखेगा, इन विच यू कैन सी the black 4 circles, 4 atoms are corners, remaining white circles are corners, and there are 2 blue circles face center, 2 red ones face center, and 2 blue ones face center. So this is nothing but face centered cubic lattice, FCC, जिसको उन्होंने सबसे पहले नाम दिया था cubic close packing. And this also has 74% efficiency. Coordination number comes out to be 12. इसका 12 निकालना शायद आपको अभी इजी जाएगा. आप ये A एटम को देखो, नीचे की लेवल में वो 6 एटम्स को कनेक्टेड है, इसके ऊपर ये C लेवल रहेगा, वहां पे भी 6 एटम्स है, तो नीचे के 6 एटम्स, ऊपर के 6 एटम्स, सो इट्स 12 कोऑर्डिनेशन नंबर. ये आप एटम्स की प्लेसमेंट, इफ यू नो बिलियर्ड बॉल जैसे होते हैं टेबल पे, बिलियर्ड टेबल पे, दैट ट्रायंगल दे कीप दी एटम्स, बॉल्स मतलब वहां पे बिलियर्ड बॉल्स, वैसे ही रखा है. ये बिलियर्ड बॉल का एक एंगल, ये फ्रंट एंगल.
Sir, but it won't it only touch 4?
No, actually not. In reality, it touches because it is a octahedral. So octahedral will touch 6 atoms. ये जो एटम है ये डायरेक्टली 6 को टच करेगा. देखो यहाँ पे इस कोनिकल जगह पे. रिमेंबर octahedral is made up of 6. So this is made up of 6. So इस लेयर में 6, इसके ऊपर के लेयर में 6. That's how the arrangement is made. अभी तक जितना हम लोगों ने देखा इसका आपको एक सीधा साधा समरी दे रहा हूं, so that you know how you will develop how the things were. नहीं तो हम लोगों ने हर एक स्लाइड में अलग अलग देखा था. अभी एक स्लाइड में आपको मैं पूरा डेवलपमेंट दिखा रहा हूं. जिनको कुछ भी डाउट था अब ये स्लाइड एकदम प्रॉपर समझ लो. We had taken one dimension first, which was like this. Then we stacked this to get 2 dimension, which was like this. और 2 dimension में हम लोग के पास 2 टाइप्स थे. फर्स्ट वॉज AAA टाइप, दूसरा था ABAB टाइप. सो 1 डायमेंशन को हम लोग ने 2 डायमेंशन किया, 2 डायमेंशन के 2 टाइप्स देखे. फिर वी वेंट फॉर 3 डायमेंशन. सो इन 3 डायमेंशन अगर AA वाला एक्सटेंड करते हैं हम लोग तो उससे हम लोग को मिलता है सिंपल क्यूब. ABAB को हम लोग अगर करेंगे तो हम लोग 2 टाइप से कर सकते हैं. एक हम लोग ऑक्टेट्राहेड्रल वॉइड पे कर सकते हैं, which we call as hexagonal close packing. सेकंड ऑन ऑक्टाहेड्रल जो अभी हम लोग ने देखा, तो ये हेक्सागोनल क्लोज पैकिंग और ये फेस सेंटर्ड क्यूबिक. लास्ट वी विल चेक द कोऑर्डिनेशन नंबर ऑफ ईच ऑफ देम. सो इसका कोऑर्डिनेशन नंबर था 4, इसका है 6. सिंपल क्यूब था 6, टेट्राहेड हेक्सागोनल का है 12 और इसका भी है 12. आई होप जिनको अभी तक कुछ भी डाउट है ये स्लाइड से शायद बेटर समझा होगा हाउ वी स्टैक द एटम्स ओवर ईच अदर. Shall we go ahead? No doubt up to this. इसमें से फ्रैंकली स्पीकिंग एग्जाम के लिए इसमें से कोई डायग्राम्स या बड़े डायग्राम्स जो अभी आप लोगों ने देखे वो मोस्टली कभी पूछते नहीं है. What they ask in exam are mostly this particular slide. अभी तक जितने स्लाइड्स देखे वो सभी आपके एक्सप्लेनेशन के लिए थे, लेकिन एग्जाम में आपको क्या पूछेंगे, AAA का क्या नाम है, उसका कितना कोऑर्डिनेशन नंबर है, what is meant by ABAB, what is its coordination number, if ABAB is filled on tetrahedral void, what geometry do we get. तो ये स्लाइड मुझे लगता है कि सबसे इंपॉर्टेंट आपके लिए है. ऑफ कोर्स ये समझने के लिए आपको इसके पहले के सभी पॉइंट्स चाहिए. वेरी फ्यू क्वेश्चंस आर आस्क्ड ऑन दिस सेक्शन एक्सेप्ट द वन व्हिच आई टोल्ड यू राइट नाउ. वी कम टू द इंफॉर्मेशन लिटिल मोर अबाउट वॉइड. अभी ये 2 स्लाइड्स है वॉइड स्पेस के जो HSC में नहीं है, इट्स ओनली इन नीट एंड जेई. फिर लास्ट में प्रॉब्लम्स है वो फिर से HSC के ही है. सो 2 स्लाइड्स जस्ट लिटिल एडिशनल फॉर HSC स्टूडेंट्स. void space we saw 2 times. First type was tetrahedral, second was octahedral. We take some more information about this. Tetrahedral void का जो radius होता है, it is found as 0.225 r, where r is the radius of the atom which is making the tetrahedral void. Same way for octahedral it is 0.414 into r. ऑक्टाहेड्रल जो एम्प्टी स्पेस है उसको वो लोग सर्कुलर इमेजिन करते हैं, तो उसका रेडियस इज फाउंड बाय दिस फॉर्मूला. नंबर ऑफ टेट्राहेड्रल वॉइड्स इज ऑलवेज 2 times the number of atoms in close packing, while octahedral is always the number of atoms in close packing. Let me explain this in little more one additional point. आप लोगों ने देखा था टेट्राहेड्रल में डायग्राम में एक लेयर हम लोग ऊपर रख सकते हैं एटम के, एक लेयर हम लोग नीचे भी रख सकते हैं. दैट इज व्हाई टेट्राहेड्रल वॉइड्स आर डबल इन क्वांटिटी. व्हाट आई मीन इज लाइक दिस. दिस इज द फ्रंट लेयर एटम जो 3 एटम्स हम लोग ने देखे थे. हम लोग एक एटम उसके ऊपर प्लेस कर सकते हैं. इमेजिन करो ये हम लोग ने यहां पे प्लेस किया, तो ये 4 एटम की वजह से एक टेट्राहेड्रल वॉइड क्रिएट हो गया. ऐसे ही मैं और एक एटम नीचे की तरफ से भी ज्वाइन कर सकता हूं। तो हम लोग ये 4 1 2 3 4 ज्वाइन करके और एक टेट्राहेड्रल वॉइड बना सकते हैं। सो अगर ये क्लोज पैकिंग के एटम्स हैं तो इससे हम लोग ऊपर और नीचे दो टेट्राहेड्रल वॉइड बना सकते हैं। सो इट इज ऑलवेज फाउंड दैट नंबर ऑफ टेट्राहेड्रल वॉइड्स इज 2 into द नंबर ऑफ एटम्स। ओके, इस पे बेस्ड हम लोग और छोटे पॉइंट्स आगे करेंगे, बट रिमेंबर दिस, octahedral void is produced from only 3 atoms above and 3 atoms below. So that's why there is no other level possible for this. For example, अगर आपके पास FCC लैटिस है तो फेस सेंटर्ड क्यूबिक में टोटल 4 एटम्स होते हैं, तो उसमें टेट्राहेड्रल वॉइड रहेंगे 2 into 4, that is 8. While octahedral में there will be 4 octahedral voids. So they ask a question in JEE and NEET, how many total number of voids are present in FCC? That is 8 plus 4, 12 voids. ये लास्ट पॉइंट का एक्स्ट्रा एक्सप्लेनेशन मैं यहां पे आपको दे रहा हूं. This is a diagram from NCERT where they have tried to show the octahedral voids in it. अभी पार्टिकल्स आपके यहां पे फेसेस में प्रेजेंट है और कॉर्नर में भी प्रेजेंट है. तो ऑक्टाहेड्रल वॉइड यू कैन फॉर्म ओवर हियर. जैसे आप देख सकते हो 1 2 3 4 5 6. तो इमेजिन करो ये 6 एटम्स को आपने अगर ज्वाइन किया तो ये जो बीच में एम्प्टी स्पेस दिख रहा है वो है ऑक्टाहेड्रल वॉइड. फिर हम लोग इस यूनिट सेल के साथ दूसरे यूनिट सेल के एटम लेके और एक ऑक्टाहेड्रल वॉइड एज पर क्रिएट कर सकते हैं. सो हम लोग इसका कैलकुलेशन करके देखेंगे. नंबर ऑफ ऑक्टाहेड्रल वॉइड प्रोड्यूस्ड इज 1 ओवर हियर. यहां पे एज में टोटल कंट्रीब्यूशन था 1/4 और ऐसे 12 एज के एटम्स है. सो टोटल ऑक्टाहेड्रल वॉइड्स आर 3. सो टोटल नंबर ऑफ ऑक्टाहेड्रल वॉइड आर 4. इसी को हम लोग ने पहले स्लाइड में सीधा पॉइंट लिखा था, ऑक्टाहेड्रल वॉइड्स आर 4. टेट्राहेड्रल देखते हैं. एफसीसी में टोटल एटम्स है 4, तो टेट्राहेड्रल वॉइड्स रहेंगे 2 into 4, that's 8. So total voids are 8 plus 4, that is 12. This answer is from NCERT book, but they ask usually as a direct result finally how many tetrahedral voids, how many octahedral voids in CCP lattice. We solve now. HSC students can come back in case you are sleeping in between. We have 2-3 problems to solve for void spaces. These are from your notes only. So first question, read it first, and how to solve I'll give you simple trick. बहुत simple problems है ये. Compound is formed from 2 atoms X and Y. Atoms of element Y are acting as anions and they make the CCP lattice, while X cations occupy octahedral voids. What is the formula? अभी एक ट्रिक आप लोग इसमें याद रखो ये प्रॉब्लम सॉल्व करने के टाइम. आपके पास जो एनायंस होगा Y जैसे एनायंस है, काउंट द नंबर ऑफ एनायंस एज द नंबर ऑफ एटम्स. जैसे इसके एटम्स है सपोज n. नंबर ऑफ ऑक्टाहेड्रल वॉइड्स इज ऑलवेज नंबर ऑफ एटम्स एंड octahedral voids they are saying is occupied by X. So X का नंबर भी होगा n. तो इनका रेशियो हो गया n:n, that's 1:1. Formula of the compound becomes XY. I repeat the concept again. We will always consider the anions always make up the CCP lattice. Anions are large in size, so they make the lattice. So number of atoms are suppose n. Then they have given that X is for occupying all the octahedral voids. अभी लैटिस में जितने एटम्स है उतने हमेशा ऑक्टाहेड्रल वॉइड में रहते हैं. तो यहां पे हो गया X का नंबर भी n. कोइंसिडेंटली दोनों का नंबर n हो गया, इसलिए रेशियो आ गया 1:1। चेंज करके इसका सेकंड प्रॉब्लम दिखाता हूं। इफ यू वांट विल कम बैक टू द प्रॉब्लम अगेन। Atoms of element B form HCP lattice. A occupy 2/3 of the tetrahedral void. What is the formula? So, number of atoms of B we are considering n. So, यहां पे tetrahedral void हमेशा होते हैं 2 times that of n. So, they are saying A is occupying only 2/3 of this place. So, atoms कितने होंगे? 2n into 2 by 3. That's 4n upon 3. ये नंबर हो गया मेरा A का, और B का नंबर अपने पास है n. सो रेशियो हो गया 4n upon 3 is to n. That is 4:3. So the formula becomes A4B3. Yeah. So just go through this. Any doubt about this part, please let me know. I repeat the basic concept again. We are going to take again the anions which are going to form the lattice. Over here they are saying B. Tetrahedral void number is double of that number, and then find a ratio. Let us take another one based on this. Zinc sulfide crystallizes where zinc ions are occupying half the tetrahedral holes. Closed array packing is of sulfide ion. What is the formula of zinc sulfide? So let us see step by step. Sulfide ions are occupying octahedral voids. So let us say number of sulfide ions are n. Tetrahedral voids will be 2 times n. But the condition says zinc ions are occupying half the tetrahedral voids. So 2n upon 2, it will be n. So now the ratio of zinc and sulfur is going to be n is to n, 1:1. The formula of zinc sulfide is ZnS. One more, and please tell me the steps before I display it now. All of you, please try this. Aluminium oxide crystallizes with aluminium ions in 2/3 of the octahedral holes. 1/3 octahedral hole remain vacant. What is the formula of aluminium oxide? Whatever comes to your mind, please tell me. There are two elements, aluminium and oxygen. Who will form the lattice? Aluminium or oxide? Who will form the lattice? Please tell me.
Aluminum.
Once again, I repeat the concept. Anions always make the lattice. Remember this concept. Anions always make the lattice. So oxide is always going to make the lattice. So oxide will occupy the octahedral holes. So now here, number of oxide ions are suppose n. Now tell me the next step. What about this one? Aluminium is occupying 2/3 of octahedral holes.
2/3 N.
2/3 of n. Oxide is going to be n. So it is n cancelled, 3 cross multiplied. It's 2:3. So the formula becomes Al2O3. Remember the golden sentence, anions make the voids, and cations occupy the space in them. Let me write here. If you want, you can take a screenshot and remember it. Whenever we have a cation and anion, anions are going to make the lattice. Now, when you make a lattice, there will be atoms placed somewhere like this. There will be an empty space between them. This is the void space between them. And this will be filled with cations because cations are small in size, anions are larger in size. So cations can go and fit inside this empty space. So lattice is made of anions. Empty space created, tetra or octahedral, whatever they say, will be cation. अभी आपको क्या देखना है, हमेशा प्रॉब्लम सॉल्व करने के टाइम आपको एनायन का नंबर हमेशा, अगर कुछ दिया नहीं है तो n लेना है. फिर कैटायन का आप कंडीशन देखो, अगर टेट्राहेड्रल बोला है तो यू विल टेक इट एज 2n. If they say octahedral, it's possible sometimes cations are present inside octahedral, then you take it as n. और फिर ये स्टेप नंबर 1, ये स्टेप नंबर 2. स्टेप नंबर 3 में अगर कोई कंडीशन दिया है क्या, देखो जैसे 2/3 ऑफ दैट, 1/3, वॉट एवर, इफ एट ऑल. अगर कुछ भी कंडीशन नहीं है तो सीधा कैटायन इज टू एनायन का रेशो निकालो. That ratio is the final answer. Those who found the problems difficult, see if you understand this scheme of solving the problem. If you want, take a screenshot of this, and if you feel, I will show the problem once again, keeping this scheme in mind. तो शायद आपको समझ में आएगा. ये टाइप के प्रॉब्लम आप अच्छी तरह करके जाओ. बोलो.
Sir, in the final problem, there was one line, the 1/3 of
हाँ, so मतलब
1/3 void
2/3
is.
is occupied, 1/3 is empty. तो उसका हम लोग
So
कुछ
we won't
use नहीं
take that.
करेंगे. हाँ, उसका कुछ यूज नहीं करेंगे. Whenever they say, see, we see always the filled part, we don't see the empty part, because empty part में atom है नहीं, तो उसका कुछ अपने को फॉर्मूला में यूज नहीं है. चलो, कीपिंग दिस इन माइंड, आप लोग एक बार एक फिर से प्रॉब्लम, एक दो प्रॉब्लम फिर से दिखाता हूं, जिनको थोड़ा डिफिकल्ट लगा था ये टाइप, फिर से देख लो एक बार. मैं आपको सेकंड प्रॉब्लम दिखा, यस, ये वाला प्रॉब्लम पहले देखो, अभी आपके शायद समझ में आएगा. बी फॉर्म द लैटिस. जिसने लैटिस फॉर्म किया उसको मैंने n लिया. ए ऑक्यूपाई टेट्राहेड्रल वॉइड, तो इसके लिए मैंने ए को 2n किया टेट्राहेड्रल के लिए, फिर उसको मैंने 2/3 किया, एंड देन आई टुक अ रेशो. आई होप द स्कीम एंड द प्रॉब्लम अंडरस्टूड, आई थिंक. और एक देख लो, जिंक सल्फाइड वाला. अगर कुछ भी बोला नहीं है तो हम लोग एनायंस को सीधा क्रिस्टल एक्सेप्ट करेंगे. सल्फाइड आयन n atoms, tetrahedral 2n, then the condition is mentioned half the tetrahedral, so 2n upon 2, that is n. फिर ऐसे देख लो, oxide will be n. Aluminium they are saying 2/3 of octahedral only, इसलिए मैंने 2/3 of n किया. अगर वो लोग बोलते थे 2/3 of tetrahedral, so I would have taken 2/3 into 2n. Then we find the answer. Last part of this, ये मैंने आपको डी ब्लॉक के टाइम बोला था. आई एम रिपीटिंग दिस अगेन टुडे. Which elements show which category of type? Cubic close pack कौन दिखा रहा है, hexagonal, body centered, and so on. That is the thing. You don't have to by heart this at all, but this is given in NCERT and all the textbooks. NCERT में ये डी ब्लॉक के अंडर उन्होंने दिया है, लेकिन वहां पे कुछ समझ में नहीं आएगा, इसके लिए मैंने आपको ये यहां पर दिखाया है.